Okay, so for the in-person kids, this is just a nice review that goes over all the problems in my explanation of them. Also, for the virtual kids, just a reminder that you have to get on the Google Meet to take the test. And I post those times on Classrooms, so make sure you're checking those. So it says evaluate each log expression, give the exact values. So really what we need to know is how to rewrite it. So I'm going to rewrite as an exponential equation. So 3 to the what power gives me 27. Well, hopefully you know it's 3. Another way to think about this, we can do log of 27 over log of 3, change the base. You can solve from there too. Next one, same thing, we're going to rewrite. 5 to the what power equals 1/5. Well, we know 5 to the first gives me 5. But if I want to make it 1/5, it's going to be a -1. Next one, 27 to the what power gives me 1. Well, hopefully you know if the exponent is 0, it's always going to be 1 as your answer. And lastly, 7 to the what power gives me the square root of 7. Well, hopefully you know, again, the square root of 7, the exponent is 1/2. Next one, 8, log base 8. Those are going to cancel, so my answer is just 19. Natural log and common base e, again, those cancel, so my answer is just 6. On G, 2 to the what power gives you 8? Well, you can try numbers, but you should know it's 3. And lastly, 27 to the what power gives you 3? This is the tough one because the base is bigger than the answer. So you know you're going to have a fraction exponent. Well, I know 3 to the third gives me 27, so I'm going to make it 1/3 as my exponent. Okay? Number 2, it says graph each of the functions and identify the following. We're not going to worry about domain and range. Instead, we're going to worry about the asymptotes and the transformations. So just a reminder, all right, asymptotes, if it's a log, it's usually x equals 0. If it's an exponential, it's usually y equals 0. And then the transformations will change that. So this first one, here's what I started with. Here's what I ended up with. So remember, that's a reflection over the y-axis. Now think about this. If I have a log equation, I flip over the y-axis, it's still not going to change my asymptote. So it's still x equals 0. Next one, start with this. Here's what I ended up with. Plus 1 out front is not multiplication. So that just means it's going to be up 1. This right here, all right, is telling me that I'm going to go left 2 because it's a positive 2. And that's a flip over the y-axis. So if you think about this one, 1 plus log of 2 minus x, all right, I'm going to move it left 2, and then I'm going to reflect it over the y-axis. So if I go left 2, it's going to be at -2, but then I flip it, so it's going to be at +2 for your asymptote. Next one, here's what I start with. These are exponential functions, so now it's y equals instead of x equals on your asymptote. Negative out front means reflection over the x-axis. And the +3 means I'm going up 3. So my asymptote, if I flip it over the x-axis, it's still going to be y equals 0, but then I move it up 3, so it's going to be y equals 3. Last one, it's a stretch by 2. And I'm going to go down 1. And again, it's just going to change your asymptote to -1 because it was at 0, but if I move it up or down, that's what changes it. So up or down changes this one. Left or right changes this one. So if it's a log, left or right is going to change it. If it's up or down, it's going to change the exponential ones. Rewrite as a single log. This is something we kind of struggle with. So you see how they both have log in it? So I'm going to start the equation with log, and then I'm not going to write log ever again. So now I got to look at the x and the 3 log of y. So if it's a plus sign, that means I'm going to multiply. So I'm doing x times y to the third. The 3, remember out front, is the exponent on that specific log. Okay? Next one, I go to the right. They're all log base 2. Alright, this one I'm multiplying x and y, but it's a 1/2 out front, so it's a square root. And then I am subtracting x plus 2 to the second. So that means I'm dividing by x plus 2 raised to the second power. And again, they all had log base 2, so I just wrote it one time, and that was it. Alright, next one. They have log base 3, so I'm going to start with log base 3. I'm going to say x plus 6 to the 4th over x to the 3rd, because it's a minus. Right, and the exponent's the number out front, and whatever it's attached to. Next one, log base 7. So again, I'm just going to write it one time. This is x squared minus 4x minus 21 over x minus 7. This one's a little bit harder because you can actually factor the top. But factor the top, it factors into x minus 7, x plus 3 over x minus 7. So notice x minus 7 is going to cancel. So I have log base 7 of x plus 3. Next one, I'm adding and I'm subtracting, so it's going to be multiplication and division. It's going to be x to the 5th, or x to the 3rd, sorry, y to the 5th over z to the 6th. And then last one, threw in another factoring one. So hopefully you know the top's going to factor into 3x minus 4, 2x plus 3 over 3x minus 4. So those are going to cancel, so I'm going to have log base 7 of 2x plus 3. So now we're going to rewrite them as a sum or difference. So all of these are going to have log base 5. So let's start with the first one, log base 5 of 125. I'm dividing by y. So I'm going to do minus log base 5 of y. This right here is what we just did at the top. You can simplify it. So 5 to the what power gives you 125? Well, that's 3. So it's going to be 3 minus log base 5 of y. Next one, log base 7. Let's start with the x. Remember, the exponent is 1/2 if it's a square root. I'm going to add 5 log base 7 of y. And I'm going to subtract 7 log base 7 of z. Again, exponents just go out front. They all have log base 7 in them. I just go to each letter / number individually. So we're going to split this up. I'm going to do the x first. Log base b of x, so it needs to be a 2 out front. So that's the x. Now let's go to the y. Log base b of y. And then I'm going to subtract 2 log base b of z because I was dividing by z squared. Last one. Log of 5 plus, so 5 is its own thing. Then I go to x, 4 log of x plus 2 log of y minus 3 log of z. And that's rewriting it as multiple logs. So now it says use change of base formula to find a decimal approximation to 4 decimal places. So I'm going to do log of 12 divided by log of 2. Type that in my calculator. You should get 3.5849. All right, next one, I would do log of 3 squared, which is 9, over log of 5, which is 1.365. Lastly, I would do log of 2/7 over log of 9, which is negative 0.570. Again, you just type those into your calculator, change base formula. Solve each equation if necessary, find an approximate solution. You could round it. So on A, okay, what I would do is I would ask myself, can I rewrite these to where they have the same base? So is there 2 to a power that gives me 64? Well, there is. That's 2 to the 6. So now my bases go away, so now I have 4x minus 2 equals 6. I'm going to add 2. 4x equals 8, divide by 4. X is 2 in that case. Next one, I want to get the e by itself, so I'm going to divide by 9. E to the 5x equals 141. Now to get rid of e, you take the natural log of both sides, so here's what it's going to look like. That's going to cancel, so I get 5x equals natural log of 141. Then I'm going to divide by 5. I would type all that into my calculator, natural log of 141 divided by 5, and I would get 0.990. Remember, if it has the log base 4, we're going to write 4 as an exponential and raise it to the base on both sides, so it's going to cancel that. So I'm going to get 3x minus 5 equals whatever 4 to the third is, which is 64. I'm then going to add 5. 3x equals 69. Divide by 3. X equals 23. Next one, you're going to ask yourself, is there a way to rewrite 12,143 and 8 to where they have the same base? So if I do 8 to the 4th, I get 4,096. So if I do 8 to the 5th, I get 32,768. So that one doesn't work. So then if you can't rewrite it, okay, what you're going to do is you're going to take the log of both sides to get rid of that base 8. So I'm going to do log of 8 on both sides. I'm going to take the log of it. So then I have 3x minus 1 out front equals log of 12,143. So when you do a log, it takes the exponent down. So I'm divide by log of 8, divide by log of 8. So I get 3x minus 1 equals 4.523. I'm going to add 1 and divide by 3. So you should get 1.841. Next one, 3 plus 4 natural log of 2x. Okay, I'm going to subtract 3. You get 4 natural log of 2x equals 12. I'm going to divide by 4. Natural log of 2x equals 3. Remember, you take e to get rid of natural log, so I have 2x equals e to the third and e to the third. We're going to leave like that until we can type it into our calculator and then divide both sides by 2 to get 10.043. Last one, I'm going to add 7. E to the 12 minus 5x equals 180. Okay, then you're going to take the natural log of both sides to get rid of e. I'm going to subtract 12. I'm going to divide by negative 5. So I get 1.361. Suppose that you have $5,000 to invest and choose a savings account that has a 5.25% annual interest rate. Using the formulas provided below, determine how much is in the account after 5 years if the interest is compounded as described in each part. So if we do this annually, all right, you're going to use the first formula. I'm going to say 5,000, 1 plus 0.0525 divided by 1, because that's what annually means. 5 times 1 gets 5 years. I get $6,457.74. B, it says quarterly. So I'm going to say 5,000, 1 plus 0.0525. My interest rate unchanged, but now it's a 4 instead of a 1. So I should get 6,489.79. Next one, 5,001 plus 0.0525. This is monthly. So again, I'm going to change that in to a 12. 6,497.16. D is continuously, so now you're going to use the other equation. So I'm going to say 5,000 e to the 0.0525 times 5. Should get 6,500.88. Then lastly, it says if you choose option D above, how long would it take to triple your money? So if I triple my money, it's 15,000 equals 5,000 e to the 0.0525t. I divide by 5,000, divide by 5,000. You get 3 equals e to the 0.0525t. Remember, you got to take the natural log of both sides. So I have the natural log of 3 equals 0.0525t now. Divide by 0.0525. Divide by 0.0525. And you should get 20.93 is your t. So it takes about 21 years. Okay. Last one, it says Hermione Granger has been studying the growth of Hogwarts. So growth is the key word there. Student population over time. She has found the population in the year 2010 was 780 students, and the population should continue to grow by 4.5% now that Voldemort is defeated. Determine the student population in the year 2020. So we know there's a difference of 10 years. Okay. And we know we've got to use the growth formula. So it's 1 plus r to the t. So I know it's 780 to start with, 1 plus 0.045, and then my time is going to be 10. So I get 12,000 or 1,211.316 when I solve that. So you're going to have 1,212 students because we can't have half a student or anything like that. All right. Next one says biologists use the log model. N equals k log of a to estimate the number of species that live in a region of area. In the model, k represents a constant. So 1,300 species live in a rainforest of 600 square meters. Then how many species will be left when a third of this rainforest is destroyed by logging? All right, so we need to find k. So I'm going to say 1,300 equals k times log of 600. All right, log of 600 is 2.778. So then I'm going to divide by 2.778, divide by 2.778. My k is 467.963. So I'm going to say n equals 467.963 times log of a third of the rainforest. Means that I'm going to take away 200, so it's going to be log of 400. I'll type that into my calculator. I'm going to get 1,217.668. And it says, how large is the area of rainforest that holds approximately 330 species? So I'm going to set it up. 330 equals 467.963 log of A. Divide by my 467.963. Divide by my 467.963. So I have 0.705 equals log of A. To get rid of a log, you make the base 10 on each side. So it's 5.070 equals A. So 5 square kilometers. Last one, half-life. You've seen this one quite a bit. So on A, we know we always set up like this. 1/2 equals 1 times A to the whatever the half-life is. In this case, it's 5.76 minutes. So I'm going to get 1/2 equals A to the 5.76. So I take the log of both sides in order to get the exponent down. So I'm going to divide by 5.76, divide by 5.76. I get negative 0.052262 equals log of A. And then get rid of log, right? Raise it to base 10. So 10 to the negative 0.052262 is going to equal A, which is 0.886621. So then B and C are pretty easy. You're just going to use what you got. And now it says how many of a 1 gram sample remains after 10 days. So I'm going to say 1 times 0.088621 to the 10th, which gives me 0.300 grams. And then C, it says after 2 minutes. So I'm going to say A of 2 equals 1 times 0.886621. That shouldn't have a 0 there. That should be out to the second. And I get 0.786 grams. Okay? So that is the test. That's just a review. I know hopefully you did the review and you just watched just to double check your answers. If you have any questions before you take the test, please let me know. I'm more than happy to help. Otherwise, we will see you guys later.